Hello everyone, welcome to my channel Middleware Technologies. Today we are going to look at a very important feature of Linux kernel, that is Cgroups. So what is Cgroups? Cgroups, also known as control groups, is a Linux kernel feature that allows us to allocate resources such as CPU time, system memory and network bandwidth, or a combination of all these resources to a group of processes in a running system. So let us try to understand this data. So we have a system, that is a Linux system that is running. So this system has a set of processes, that is some are system level processes and some are application level processes which are launched by the user. So we need to have some kind of a way to allocate these resources, allocate the system resources to these processes so that every process is given equal priority. It should not be a case wherein a process with a large number of child processes allocated more resources rather than a different other process which is of higher priority. So this is where that Cgroups plays a very important role in allocating the resources based on the priority of the process. So Cgroups provides system administrators with fine-grained control. They provide a way to hierarchically group and label processes and to apply resource limits onto them. So we will see like how this can be done using a demo process. So we can monitor the Cgroups, deny access to Cgroups for resources and reconfigure Cgroups on a running system. So this is something that we can do on a system wherein Cgroups is installed, but in the newer version of Linux systems, there is a default Cgroup hierarchy that is already created and that is binded with the systemd processes. So that Cgroup hierarchy can be used in order to manage the systemd process resource allocation. So we can use basically systemd utilities can be utilized to actually allocate or allocate resources to the systemd unit or the processes with the Cgroups. So this is how like Cgroups can be used to efficiently utilize the resources amongst the tasks and user, increasing overall efficiency. So why Cgroups? So traditional resource management moved from process level to the application level. So basically the traditional resource management that was happening before Cgroups was at the process level. So let's say a process like Apache server is allocated some resources of CPU share like 60%, and if the Apache worker processes have been increased from let's say 4 to 8, so that increase also increases the allocation that has been happened to the Apache process. So this is something that the traditional resource management does. But let's say if you have a set of processes that are running, so let's say there is a database process and there is a Apache HTTP server process. So we want to allocate resources in such a way that we want to prioritize the database server and give more allocation to that resource, to that process, and less allocation to the Apache server process. So that can be achieved using the Cgroups feature. Now let us try to understand what are Cgroup subsystems. So a subsystem is basically a resource, a single resource such as CPU or memory. So Cgroups has multiple subsystems that are from where the the resources are allocated, and these Cgroup subsystems are also known as resource controllers. So let us try to identify all the subsystems that are provided by the Linux kernel using the following file. So we can go to our Linux system and try to cat for this file, that is proc cgroups, and here it will show all the subsystems that are provided by the Linux kernel. So you can see CPU set, CPU accounting. So these are all the subsystems that can be used in order to allocate and limit the resources to the processes, or do accounting, basically monitoring the CPU monitoring the resources that have been allocated to a particular process. So here are the details of each of the subsystems. You can go through these subsystem details and try to use them to manage your resources efficiently on a Linux server or system. So some of the important subsystems that we usually use are related to CPU. This subsystem uses the scheduler to provide Cgroup tasks access to the CPU. So tasks are basically processes which are assigned resources related to the CPU using this CPU subsystem. And CPU account subsystem, it generates automatic reports on the CPU resources used by the task. So this is basically used for reporting purpose on a server, wherein we want to see, understand which processes are actually utilizing the resources more or less, and try to report on them and try to charge those tenants or the users of those resources based on the resources that they have been allocated or utilized. So you can go through all of these in detail, that can be found on the Cgroup subsystem portal. You can just search for Cgroup subsystems and you can get into the details of these subsystems. The Linux kernel actually exposes a wide range of tunable parameters for resource controllers or the subsystems that can be configured with system. So we will see how we can use those tunable parameters in order to allocate resources to our systemd services and limit those resources for that process. Now let us try to understand about the default Cgroup hierarchy. So as I said, by default, systemd automatically creates a hierarchy of slices, scope, and service units. So what is slices, scopes, and service units? These are basically a structure, a unified structure for slices, scopes, and service units are the way in which the systemd divides those processes. So let all the processes running on the system are child processes of systemd init process. So basically, whenever a system reboots or starts, there is one init process that is the root process, and from which all the child processes are initiated. So systemd provides 3 unit types that are used for the purpose of resource control. So let us try to understand what are these 3 unit types. So first is service, a process or a group of processes which systemd started based on the unit configuration file. So let's say you have some set of services that are installed on your server. Let's say we have a Redis server, we have a database server, we have an Apache server. All of these installations will have some kind of a service file that is installed on the system whenever they are used. So these service files are utilized in order to start up or control the services, let is starting or restarting or stopping the resources. So these services encapsulate the specified processes so that they can be started and stopped as a one set. So this is where the service units are come into picture. Now let us try to understand what is a scope. Basically, a group scope is a group of externally created processes. Scope encapsulates processes that are started and stopped by arbitrary processes to form. So let's say, like you have a kind of service that is started, and let's say that service is launching a browser session. So this is where the scope comes into picture. So for instance, like you have a user session, containers and virtual machines that are launched. So these all processes come into the category of scope. Now slice. Let us try to understand what is slice. A slice is a group of hierarchically organized units. So a slice is the top level hierarchy under which the services and scopes are categorized. So they are organized in a hierarchy in which scopes or services are placed. Now that we have understood about the C group hierarchy, let us try to understand the default C group. How does the default C group tree looks like, which is by default created by the by our Linux system. So let us try to run this command. Let me clear my screen. So this is how the C group hierarchy or the systemd process hierarchy looks like. So this is our top level slice, or we can say it as a root slice, under which we have user slice, wherein the user level processes or sessions that have been initiated come into picture, and we have scope, we have scope level, wherein the externally triggered system, the processes come into picture, and we have system slice, wherein we can see the services that have been initiated by the system on the reboot. So these are some of the services that you can see like have been started up as soon as the system is restarted. We can also have additional slice, that is machine slice, which is used as a place for all the virtual machines and Linux containers that are launched in a virtualized environment in a system. So now let us go to creating control groups. So there are two types of control groups that we can create. That is, one is a transient control group and the other one is a persistent control group. So let us try to understand what is a transient group and what is a persistent control group. So to create a transient control group for a service, start the service with systemd run command. So we need to use the systemd run command in order to allocate resources to a particular process and initiate a transient C group. To assign a persistent C group, we need to have some kind of a service or a scope unit files which can be used to allocate the resources. So unit files created dynamically with the API calls are transient and exist only during the runtime, and the transient units are released automatically as soon as they finish or get deactivated, or the system or when the system is rebooted, so they are like wiped out. From a systemd perspective, a cgroup is bound to a system unit configuration file with a unit file and manageable with systemd command line utilities. So this is very important. So whenever a process is launched, that is assigned or allocated as a related system unit configuration file, which we can use to manage the systemd process, and it can also be used to allocate the resources for that particular process. Now let us try to create a transient group. So let us try to run a command that is sleep 1000 in a service unit named sleep test. So we will be creating a transient service unit file that is sleep test under a new slice that is my slice. So now let us try to run this command. Let me clear my screen over here. So now what we are doing is we are creating a unit file named sleep test under the slice my slice, and we are going to run the following command in that particular slice using the systemd run. So this is going to create our transient group which is going to be available as long as the service or the process that we launched is going to run. So as you can see, it has created a following transient unit file, and now let us try to understand where this service is created in our systemd hierarchy of the processes. So before that, let us try to see if our process is running using ps-ef and grep sleep. So we can see the process is running. Now let us try to see the cgroup tree to identify our new slice and the process in the hierarchy by running sudo system cgls. So let us try to run it again, and let us go a bit down, and you can see we have created our my slice, which is under which the sleep test service has been initiated, and this is the process that has been launched. So this is how we can create a transient service under a particular slice, and we can allocate now resources for this particular service using systemd. The systemd service that we launched maps to cgroup hierarchy at the following location. So we can look at the following cgroup hierarchy wherein the systemd process is mapped to. So you can see the systemd process is available over here, the sleep test service that we launched. Now let us try to understand or create a persistent group. For that, what we will be doing is we will be trying to install the service, which will create a service or a unit file which can be used to manage the httpd process. So let us try to install httpd service. So now our httpd process has been installed. Let us try to check the status of the httpd process. So this is not running as of now. Let us try to start the service and check the status again, and you can see the httpd process has been started, and it has the corresponding service unit file that has been created at the following location. So we can now try to assign resources to the following HTTPD service. So as of now, you can see these are the memory allocation that has happened to this process, and this is the CPU time that has been allocated to the user by the following process. So now let us try to see how we can allocate resources to the following service. So here, for allocating resources to the persistent cgroup persistent service, we need to run the following command. Allocate it using the systemctl utility by passing the tunable parameters that are these parameters for allocating resources to the service using the following command. So let us try to allocate the following resources, that is CPU share of 600 and memory limit of 500 MB to the following service using the following systemctl set property. So let us try to run it, and now if you check, now we need to do a systemctl daemon reload in order for the changes to take effect. And now we can check the status of the HTTP service, and you can see the limit has been set to 500 MB and CPU share has been allocated with 600. So you can see these are the configurations that have been allocated, the resources that have been allocated. If you want to get into the further details, like you can just go to the following location and look at the files, like what is the allocation for CPU and what is the allocation for memory. So this is how we can apply or allocate resources to a systemd process using the systemd utilities, that is systemctl. And you can get into the details of the resource control, systemd resource control at the following man page. So this is very detailed, which helps you understand how systemd is mapped to the cgroups and how we can manage our resources using the systemd utilities for the systemd process. So this is what I wanted to show you in this video. I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.